Hi guys, this is lesson 6.4, Application of Vector Addition. A rectangular vector component exists when we have two vectors who are perpendicular to each other are added together to give off a new vector. An equilibrium vector is one that balances another vector or a combination of vectors. This vector will be equal in magnitude
but opposite in direction to the other vectors, so as a result, the addition of all the vectors will be equal to 0, and we will have an equilibrium.
Now let's take a look at example 1 from your learning resources. A clown with mass 80 kg is shot out of a cannon with a horizontal force of 2,000 Newton. The vertical force is the acceleration due to gravity, which is 9.8 meters per second times the mass of the clown, and this would be in newtons. First, find the magnitude and direction of the resultant force on the clown. Then find the magnitude and direction of the equilibrium force on the clown. Anytime when we're asked to solve these questions, the easiest thing to do is draw a diagram. In this case, we have a horizontal of 2,000 newtons because it says the horizontal force of 2,000 newtons. And then we will have the force due to gravity, which will be gravity, which is 9.8, times the mass of the clown, which is 80, and that will give us 786 Newton, and that will be this line pointing straight down. The resultant vector, when we add these two together, will be the force, which is what we try to find in question A. So now that we have this diagram, it's easier to see what we should do next. We have to use the Pythagorean theorem, and we use it to find the magnitude and the resultant. So the magnitude of the resultant force squared is going to be 2,000 squared plus 784 squared. And that's going to give us 2,148 newtons for the magnitude of the resultant force. To find the direction of the resultant force, we have to use trigonometry. Let A represent the angle of F to the horizontal. We have tan A is equal to 784 over 2,000, which is equal to 21 degrees. Therefore, the resultant has a magnitude of about 2,150 Newton and the direction of 21 degrees below the horizontal. For question B, we have to draw the equilibrium on a diagram, which will look something like this. Excuse the roughness of the drawing. This should be a straight line that's connected. So we will have 2,150 newtons going this way to the east, south, and 2,150 to this way, which is the northwest. And this will have an angle of 159 degrees to the horizontal. So the equilibrium has a magnitude of about 2,150 newtons and a direction of 159 degrees counterclockwise from the horizontal. A heading is a direction in which a vessel is steered to overcome the other forces, such as wind or current, with the intended result direction being the bearing. So one example of a question is a boat is trying to sail across the water of a certain distance, but there's a wind current of a certain speed. So how should the boat steer, or in what angle should the boat try to go so that it will have a straight path? The ground velocity of the velocity of an object relative to the ground. It is the resultant or bearing velocity when the heading velocity or air velocity and the effective wind or current are added. Okay, and that's the end of this lecture. Thank you guys for watching.